For those of you who do not know me, I frequently go live on my YouTube channel. Uh, I have also uploaded a lot of math videos, uh, and also I go live and solve math problems or lecture on a math topic. So please, when you get a chance, take a look at my channel, take a look at all the math problems that I've solved all for you. If you like those videos, please give me a thumbs up and please subscribe to my channel by hitting the red subscribe button. So today we will continue on what we started talking yesterday. We were talking about, we are doing three tosses of a coin, a fair coin. A fair coin means equal weight on both sides. And we are tossing the coin three times, one after another. Now each toss of a coin has two possibilities. Two. Why? Two outcomes possible, either a head side up or a tail side up. So each of them has two possibilities, each of the tosses, or two outcomes possible. So total number of outcomes are 2 for the first coin, 2 for the second coin, 2 for the third tail. Or 2 for the first toss, either a head or a tail. 2 for the second toss, either a head or a tail. And 2 for the third toss, either a head or tail. Total number of outcomes are 8. Okay, and let x be the number of heads. That means how many times head face, stand, the coin lands head face up. So let x be the number of heads. X is a discrete random variable. It can be 0, 1, 2 and 3. And the 8 outcomes possible on 3 tosses of the coin are all of these 8. For example, the first one is all 3 lands on head face up. Okay. Next one can be head, tail, etc. Now we are looking for the number of heads in each possible outcome. In the first one there are 3 heads. In the second one there are 2 heads. In the third one there is only 1 head. Look at number 4. All the 3 coins land on tail face up. No head in this one. Now each of these 8 outcomes are equally likely outcomes. What does it mean? It means that any of these outcomes can result. Therefore, the probability of each of these is 1 out of 8 or 0.125. Last time we got the weighted mean x bar of these combinations as, or these outcomes as sigma, this is sigma, sorry, sigma means sum of p x, okay, times x divided by sum of px, okay, and that worked out to x bar is equal to 1.5. If you please check out my video from yesterday, and the weighted mean is 1.5. What does it mean? It means on the average, if you toss a fair coin 3 times, you will get 1.5 heads. Okay, so this is the weighted mean, and this is the formula for it. Now if you remember variance, sigma square, this is to be read as sigma square, okay, is variance is weighted mean of squares of deviation Now you will ask, what is deviation? Deviation is difference between the number and the mean. So by this definition, sigma square will be weighted mean of the squares of deviation. Deviation is x. X is all possible, 0 to 3. X minus mu, squares of those deviation, And weighted mean means each of them will be weighted by its corresponding probability. We will sum those and then divide by sum of px. Now, last time I showed you sum of px is sum of all the probabilities will definitely be 1. Therefore, this reduces to x minus mu square multiplied by px, sum of these product. So, we have the following values of x. Remember, x is the number of heads. So, 0, 1, 2, and 3. Okay. And also notice this is the mean or expected value. Ex is expected value of this probability. Expected value. Okay, same as the mean. So first we will find out x minus mu. This will be for the first one 0 minus 1.5, which will be minus 1.5. Next one, because the mean is 1.5 as written over here. So this will be 1 minus 1.5 is minus 0.5. Next one will be 2 minus 1.5 is 0.5. And the last one is 3 minus 1.5, which is 1.5. Notice we have a negative 1.5, a negative 0.5, a positive 0.5, and a positive 1.5. So as statisticians do, when we get negative numbers, if we add them together, the negatives will cancel the positives. So they do not want to cancel the negative numbers with the positive numbers by adding them. Instead, they first square this. X minus mu square. This will be negative 1.5 square. Now, as you know, a negative 1.5 multiplied by a negative 1.5, two negative sign will make it positive, and it will be 2.25. Similarly, the next one will be minus 0.5 square. A negative 0.5 multiplied by a negative 0.5, two negatives make this a positive 0.25. And this is already positive, so this will be 0.5 square, which will be 0.25. And 1.5 square will be 2.25. Okay. Now we have to multiply the squares of these differences, squares of the deviation. So this is the deviation column, x minus mu. This column is deviation square. Okay. And now we will multiply the deviation squares with the corresponding probability. But before we do that, let me list the corresponding probabilities. Okay. So let's list the corresponding probabilities. Okay. Divided by 1 because sum of the probabilities is 1. So finally the variance is squares of the deviations multiplied by the corresponding probability, add the products up. Because the denominator, let me write this out a little bit clearly so that it does not. So sigma square is sum of x minus mu square times px. So it is the weighted mean of the squares of the deviation. Hence, by definition, it will be sigma x because this is the square of the deviation multiplied by the corresponding probability, which is the weight. The probabilities are the weight divided by the sum of the probabilities. And the sum of the probabilities is 1. So, is equal to sigma x minus mu square multiplied by corresponding probability divided by 1, which finally reduces to x minus mu square times probability of x, and the whole thing is summed. Okay, so let me list the probabilities. Notice how many times 0 appears, only once. Hence this probability is 0.125. Okay, x appears 0, probability is 0.125. How many times 1 appears? 1, 2, 3. So it is 3 times 0.3 is 1, 1 and 1. Okay, 1 head. 3 times it appears in this possible outcomes. 3 multiplied by 1/8 probability of each is 3/8, or 0.125 times 3 is 0.375. How about 2? 2 heads also appears, 1, 2, 3. So 3 times 0.125, the probability is 0.375. Okay. How about 3? Appears only once. So its probability is 0.125. Okay. Now we are going to find out the product of the deviation square times the corresponding, this is mu is the mean, times the corresponding probability. So this multiplied with this. Okay. So we will be using our calculator to get these numbers. Multiply this column with this column. Okay, so this is 2.25 times 0.125, and the answer is 0.2813, you might say. 0.2813. Next one is 0.25 times 0.375, and the answer is 0.09375, or you might say 38. Same for the next one, 0.0938, because this multiplied this is same. The last one, 2.25 times 0.125, will be the same as the first entry, 0.2813. Now we will add the probability column and the product of the squares of the deviation times probability to find the weighted mean of the squares of the deviation, which is the variance. If you add this probability, it will be 0.125 plus 0.375 plus 0.375 plus 0.125 is 1.0. As you would expect, sum of the probabilities is 1. Okay, because there are only 4 possible outcomes, well, 4 possible number of heads, 0, 1, 2 and 3. Remember, x is the number of heads we are looking for. Let's add up the columns of the squares of the deviation multiplied by the corresponding probability. That is the last column. So 0.2813 plus 0.0938 plus 0.0938 plus 0.2813, and the answer is 0.7502. So your variance, as we defined before, is the weighted mean, right? So you're multiplying x minus mu square, weighted mean of the squares of the deviation, weighted mean of the squares of the deviation from the mean, multiplied by the corresponding probability, divided by sum of probability. This is the definition of weighted mean. So sigma square is the weighted mean of the squares of deviation, of the squares of the deviation from the mean. Okay, weighted mean. How do you weight? Each of these is multiplied by the corresponding probability. On top of that, you divide them by the sum of the probabilities. So in our case, it's 0.7502 divided by 1, which is 0.7502. So this is your variance, sigma square. How do you get this formula? Remember, this is a binomial probability situation. Because why? Because either you get a head or a tail. Number of times, n is number of times, number of tosses, okay, is 3. Your probability of success, small p, is probability of getting a head. Probability of getting a head. As you know, it will, in the long run, that will be equal to 0.5. So your sigma square variance in a binomial probability is n times p times 1 minus p. So if we plug in the value of n is 3 multiplied by probability of success is 0.5 times 1 minus 0.5. Let's see what we get. Okay, so it is 3 multiplied by 0.5 is the probability of success of getting ahead. In parenthesis, left parenthesis, 1 minus 0.5. Okay, close with the right parenthesis and hit enter. And this is 0.75. So sigma square is n times p times 1 minus p is 0.75, which is same as what we got, which is sum of x minus mu square times px divided by sum of px, which is 1. Hence, this is the formula for the variance of binomial distribution, sigma square. Binomial distribution. Again, what is binomial? Two outcomes, either you get a head or a tail, and the formula is n times p times 1 minus p. Why it is so? Because it is identical to sum of the squares of the variation multiplied by corresponding probability. Because this is the formula for a discrete probability distribution. So this is a binomial probability which is equivalent to a discrete probability distribution. And the formula for that is variance is the weighted mean of the squares of the deviation. So first I calculated by the formula for a discrete probability distribution, which is the weighted mean of the squares of the deviation as 0.7502, and I showed it is identical to the variance formula for a binomial probability, which is sigma square is n times p times 1 minus p is also 0.75. Now the question becomes, what is the standard deviation? So the standard deviation is the square root. Standard deviation is the square root of variance. Square root of 0.75. And that I will use my calculator. I'm using a TI-84 calculator. So I press the second button on the top left, then excess square button halfway in the first column. Second and excess square will give me the square root, inside which I will type 0.75 and hit enter. And the answer is 0.866. So that is the standard deviation. What is the meaning of standard deviation? It is an average deviation from the mean. Average deviation. Like variance is the square of the average deviation. Standard deviation is just an average deviation from the mean. The square part is gone because standard deviation is square root of variance. So in this problem I worked out the variance of the discrete probability distribution using the formula that variance is a weighted mean of the squares of the deviation. Use the formula for the weighted mean of a discrete distribution. In this case, weighted mean of the squares of the deviation. That's why in the numerator I have sum of x minus mu square, which is the deviation from the mean. Square it, multiplied by corresponding probability. Why did you multiply by corresponding probability? The probabilities are listed in this column. That is because the probability is like a weight. And for a weighted mean, this is the formula for the weighted mean, is sum of W, okay, Wi times Xi. The Wi are the weights. In my case, the Wi, which are the weights, individual weights, that's why you have I, individual weights, is same as the corresponding probabilities in this case. So in my case, the formula for the weighted mean, this is the formula for weighted mean. When you have weights which is identical to probability, is sum of Pi times Xi divided by Pi, remember, is the probability, individual probability of Xi, which I have listed over here, divided by sum of probabilities. Now fortunately for me, sum of the probabilities is 1. So this is the formula I will use. So when I am finding the mean of the squares of the deviation, Xi becomes x minus mu square multiplied by its corresponding probability. The goal was to show that if we use the discrete probability formula for the variance, which is sum of x minus mu square times px divided by sum of px, is that identical to what we use for binomial probability variance, which is n times p times 1 minus p. And indeed it turned out to be that, because my n, tossing the coin 3 times, is 3. Probability of success, probability of getting ahead in each toss is 0.5. So 3 times 0.5 times 1 minus 0.5, 0.75, which is identical to what we got using the discrete probability distribution. Point to remember here that the variance is a weighted mean of the squares of the deviation from the mean. Why did we square the deviation from the mean? Because some of the deviations are negative, some are positive. If we add just the deviation, we will get 0. Hence we square it. In that case, the negative deviations become positive. Then you take the squares of the deviation multiplied by its corresponding probability. I will stop here today. If you have any question, you can always write me a question. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. If you like this video, share with your friends. And please subscribe to my channel by hitting the red subscribe button. Okay? And please do not forget to check me tomorrow when I will be back with another interesting video. Thanks for watching. Take care. Have a nice day. See you tomorrow. Take care. Have a good day. Thank you.